Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 4th March 2023. The problem statement for today is best node. This is based on DFS concept of tree. Let's now open this problem. First, we will try to understand this problem clearly. Here it is said that you are given a tree rooted at node 1. The tree is given in the form of array P, where Pi denotes the parent of node I. Also, P1 is equal to minus 1, as first 1 is the root of every node. Every node I has a value associated, that is AI associated with it. At first, you have to choose any node to start with. After that, from a node, you can go to any of its child node. You have to keep moving to child node until you reach a leaf node. Every time you get a new node, you write its value. Let's assume that its integer sequence that the integer sequence in your path is b. Let us define a function f over b, which is defined as follows. Function of b is b1 minus b2 plus b3 minus b4 plus b5 and so on. You have to find the maximum possible value of function b. So here it is said in this question that we will be provided with two arrays here. One will be array A and array P. So P will contain all the information about the parent node of the node which is there in the sequential order, that means index wise, position wise, and A array contains some value associated with it. So we have to find the maximum possible value of function which takes over B, and how that function is calculated. So this is based on calculated with this formula, where we are adding the first value, subtracting the second, adding next value, subtracting the subsequent one. That means alternate one. Once it is positive, once it is negative. So here it is said that we can start with any node, but we have to return the maximum possible value of function b. So here if we go through this example, then here it is said that array A is containing 1, 2, 3, and parent array is minus 1, 1 and 1. So here it is said that output is 3. So even the explanation is given here. The resulting tree is 1, 2 and 3, where see if you look at this parent array, here it is said that for first array that is minus 1. So that is not, so that is the root node, that means the parent node. And for the second array, for the second child, this first node is the parent. Even for the third node, even for the third node also, the first node itself is the parent. That's why the tree structure this way, that first node contains two children, that is 2 and 3, and the value associated with 1, 2 and 3, that is 1, 2 and 3 here. So if we choose our starting node as 3, then the resulting sequence will be 3, because 3 is not containing any more child node, which is the given maximum possible. Okay, so if we try to choose any other array in this one, so if we start with 1, then so here the value will be 1 here. Then for the next one we have to subtract the value from here. So from 1 we can go to either 2 or 3. There is no connection between these 2 and 3. So from 1 we can, if you go to 3, then the value will be minus 1. If you go to 3, then the value will be minus 2. How we got to minus 2? Here it is 1 minus 3, because if you look at this formula, then whatever is the second node, that we have to subtract. So it's better in this one to start with the first node, to start with the leaf node itself, because that contains the maximum value. I hope this point is clear. So now let's look at this second example. Here it is said that n is equal to 3, and this is the given associated value of all the nodes and the parent information. Here it is said that if you look at this parent array again, so for the first node the value is 3, but that is the root node since its parent is minus 1. But for the second node, the parent is first node, and for the third node, the parent is second node, and the value associated with is 1 and 2 respectively. So here it is said if we choose our starting node as 1, then the resulting sequence will be B, that is 3 1 2. And how we are calculating B? That is based on the value given in array A. So the value which we will get is 3 minus 1 plus 2, because here this one, the second node we are subtracting, third node we are adding, fourth node we will be subtracting, fifth node we will be adding. So we have to wisely choose the starting point in such a way that we have to get the maximum possible value out of that function f. So for this one, we have to explore all the solutions. That means starting from any node, we have to visit all the child nodes and explore all the possible outcomes for each node. That means we have to start with the root node, then its child node, then its other child node, and if that child node is having some other child, then for each of the node we have to explore various solutions and see from which node we are getting the maximum value. So for solving this problem, the only solution that comes to my mind is using the DFS. So DFS is the depth first search which we'll be using in this problem to explore all possible paths from each node to its leaf node. The idea is to start from each node and traverse down to its leaf node while keeping track of some of the nodes value along the path. DFS is the natural choice for tree traversal because it explores the tree in depth first order, which means it visits all the nodes in a branch before backtracking to explore other branches. This is exactly what we need to do in this problem, because we want to traverse down the leaf node of each branch to calculate the sum of node values along that branch. Moreover, to keep track of whether we need to add or subtract the node value at each step of traversal based on the value of the node in the path, DFS allows us to pass a boolean flag along with that the recursive call to keep whether we have to subtract or add the node value based on the level of the node. So for that reason we will be using DFS in this problem. So the overall approach for solving this problem will be that along with the DFS, we will first initialize the adjacency list where each node in the tree has a list of its children. Then for each node in the tree, it performs a DFS starting from that node and calculates the maximum value of function f over the path it takes from that node to leaf node. Finally, it returns the maximum value of f over all the nodes in the tree. So keeping this approach in mind only. So I have already prepared a solution just to save time in typing that. So let me just copy it. Then I'll explain it again line by line. So this is the solution which I have prepared for this one. And I'll explain this line by line what is happening. So here, if you can see, we are following the approach of DFS only in this problem. So we will start with this one. First, this best node that is taking input, that is n, whatever is given there in the problem statement, then input and then array A and P. That means the parent array. Then after that, what we do? Then we iterate over this one. Then we iterate over all the nodes that means given there, and we are starting with 1, and we are creating a adjacency list, initializing it with array of 0. That means initializing it with a new array list. Okay. Then after that, from that node, starting this node again. Just a minute. Yeah, sorry. So here, so we are creating a adjacency list is an array of list where ith list contains the indices of node adjacent to its node I. In this case, adj of I is the list of all the nodes adjacent to node I. The adjacency list is created by iterating over the node from I to n and initializing the empty array for each node that we have seen here. Okay. Then the function iterates over all the nodes except the root node, which is represented by this one -1 here, and that means whatever is given in this p array. So it will iterate over all the nodes except the root node and adds the each node to its parents adjacency list. This one we are adding each node to the parents adjacency list, and we are starting with 1 here. Next, this function we are initializing a variable that is here that is answer to long minimum value, which is the smallest possible value for a long integer in Java. This variable will store the maximum possible value of function b over the possible path starting from any node in the tree. I hope this point is clear. So this variable will store the value at each node. That means if you are starting with 1, if you are starting with first node, then after this DFS method is executed, then it will contain the maximum value that was possible when we are starting iteration in the complete tree from node 1. In the subsequent time, it will check whether if the previous value when we started with node 1, that is the maximum, or when we are starting with the next value, that means next child or next element in the tree, next node in the tree. So then we are getting the maximum. So whichever is the maximum value at any given point, that will be stored in this answer variable. I hope this point is clear. Then this function iterates over all the nodes in the tree. Then for each node we call the DFS function with the current node and the adjacency list, and we are passing this array, the associated value array field, and false as the initial value of function. The maximum value of fb obtained from all the paths starting from each node is stored in this answer variable. The DFS function here it takes 4 parameters. One is node, adjacency list, this associated value array, and the function that means the boolean flag f. If f is true here, so that is a bit later here. So yeah, before that we'll see what we have done here. So this function recursively explores all the child nodes of the current node by calling the DFS method and each node and taking the maximum value of fb obtained from each node. Then for the function, this calculates the value of the current node based on the value array a and boolean flag f. If f is true, then the value of the boolean flag, the value of the current node is negated. That means we are starting with false here. So now if we are adding that one, and if we are making it false, that means if you are negating it, then we will get a false of it, a true of it. So each time if you convert a boolean flag, if you negate it, then you will get the other value from true to false and false to true. So for that it is the same thing has been done here. If flag f is true, the value of the current node is negated. Finally, if there are no child nodes, the value of the current node is returned as the base. Otherwise, the maximum value of function b obtained over the child nodes is added to the current node value and returned as the result of the function. In summary, this function creates an adjacency list to represent this entire function, creates an adjacency list to represent the given tree, and recursively explores all the possible paths from each node in the tree using the DFS function. The maximum possible value of function b obtained from all the nodes starting from each node is stored and returned as the result of the function. I hope this point is very clear. So now let's try compiling this code. So here we can see we have got our output correct for this example which is given there. Now let's try submitting the solution. So here we can see we have got our all test cases passed. So here one thing to take care is that if we talk about the time complexity of the solution which is here, so here it will be big O of n in normal case, and in worst case it might go up to big O of n square, where n is the number of nodes in the tree. The reason for this is that when we are using DFS to explore all possible paths from each node to leaf node, for each node we traverse down to its leaf node, which takes big of n time. Big of n time if the in the worst case if the tree is skewed. Since we repeat this process for all the nodes in the tree, the time complexity becomes big of n square. However, the actual time complexity of the solution will be lower if the tree is balanced, and as the worst case complexity of big of n square that can be reached only in case if the tree is skewed. Skewed means that means all the nodes is aligned in a single line. That means single hierarchy level. That means no node is having two child there. I hope this point is clear. So we have solved this problem successfully. I'll be providing the description. I'll be providing the link of this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.